I'm going to go over how to solve every single unit circle question on the SAT using a simple trick on Desmos, which is the calculator built into the SAT testing software. Now, unit circle questions are pretty rare. The only time I've seen a unit circle question tested on the official SAT was in May of 2025. So a few months ago at the time of this recording, and I haven't seen a single unit question since then. However, College Board, the people that make the SAT, recently in August, updated their question bank to include a unit circle question. It was a pretty hard unit circle question. So I'm thinking they did the May unit circle question as an experimental question to see how it goes. And then they're going to slowly start introducing unit circle questions. They first added a unit circle question in the question bank to get students used to it. Now it's been a few months. I wouldn't be surprised if you see unit circle questions on the SAT consistently. So I'll just show you how to solve every single unit circle question, no matter how hard it is, using a very simple trick on Desmos. You don't actually have to memorize anything other than just one simple thing. Okay, first of all, what do I mean by unit circle? So if I search up unit circle on Google here, and I go to images, normally, at least most tutors would tell students to memorize this. Okay, you have to memorize all of this. So at least know really well how to get all these coordinates given the angle, or get the angle given these points. And even memorizing this entire thing isn't enough to solve all unit circle questions that can be tested. You also have to know how angles work on unit circles, as well as the x and y value and how they equal cosine and sine of an angle. And I'll teach you that, which is actually going to be the trick. So just to give an example, okay? Here's an easier question. Normally how you would solve this is you know this unit circle thing, and you can solve it without a calculator. You know, oh, if on the unit circle, if the angle is pi over 3, what is the y coordinate? So you just, with the angle pi over 3, the y coordinate is square root of 3 over 2. And then you just pick a then. But you have to memorize the unit circle to be able to do that. Right? Instead, I'm going to teach you a trick, okay? So basically, all you have to know is cosine of an angle and sine of an angle is the x and the y value of the unit circle. And that's all you have to know. As long as you know this, you can solve every single unit circle question. As long as you know this and like you have a decent understanding of how Desmos works, which I'll also teach you like all you need to know pretty much by giving you some example questions, and they're gonna be really hard questions. So we can go through all this pretty in detail. Okay, so basically, what was the angle? It was pi over 3, right? So pi over 3. You just press that. There was the point. What's the y value of this? I mean, it's pretty obvious because it's positive. It's definitely not 1/2. If you look at the y value, right? So it has to be a. And you can just type in square root of 3 over 2 just to make sure they equal the same number. Yeah, 0.866, 0.866, yeah. So you could solve it like this too. You notice I didn't have to memorize any of the unit circle stuff in here. All I had to know was that cosine of an angle and sine of that same angle is the x and the y value of a unit circle. And just to be careful, something to note that's really important, sometimes they ask you to angles in degrees and not radians. Right now we're in radians. If you see pi over 3, it doesn't mention any units on the angle, that's radians. Okay, if it said if theta equals 60 degrees, then you would have to change the settings from radians to degrees. Okay, because that's how a calculator works. When you're using trigonometry, you're using an angle, it might be radians or degrees, and you have to tell the calculator is it radians or degrees. So if it said theta equals 60 degrees, because there's like a small circle at the top there, if you see that small circle, what it literally says is in degrees, then you're gonna have to change it to degrees, and only then would it give you the right answer, or else it won't give you the right answer anymore. For example, if this was in radians and I typed in 60, it's wrong, right? This is the wrong answer. It's going to put it all the way over here because this is in radians, not degrees. You have to change it to degrees. Okay, now that that's covered, let's do some really hard questions so we can really dive deep into exactly how this works. So first of all is the question in the question bank. Actually, let me expand this and give you an idea. So let's first read this question. The point F lies on a unit circle in the xy planes and has coordinates 1, 0. Okay, so let's actually just graph that just so we know what's going on. So point F, right? Point F lies on 1, so the coordinates 1, 0. That's point F. Let me label that. Okay. Point G is on the center of the circle. So I guess center of the circle has coordinates 0, 0. Okay, so let's do that. It says 0, 0 right there. So let's say G. Okay, so we have 2 points. Point H also lies on the circle and its coordinates -1, y. Okay, so you can only put in constants meaning you can't put any variables in points. So I'm not going to just type in y because it won't work. All right, it says y is a variable, x and y is a variable. Also, theta is a variable. That's why I didn't use theta when I was doing this. You can actually type in theta. You don't need to use this on the SAT ever. I just want to let you know in case you typed in theta when solving this question. You can type in theta, obviously without the space, but you just type that in, it automatically gives you this symbol. This is actually a variable. You notice it treats it the exact same as y. This is for polar coordinates. You don't have to worry about this on the SAT, but just so you know, you can't type in theta if it tells you something in theta. Okay, so you can't type in x or y or lowercase x or y with theta. So let's just type in y1. If you type a 1 right after a variable, it automatically puts the 1 or any number after a variable, or actually after any letter at all. So if I type in the q or any number, it automatically puts it as a subscript. So I can do that. Now it's a constant. Okay, it's not a variable because as long as it's y, lowercase y or x, but y1 doesn't count as a variable. So now I can make a slider for it if I wanted to and drag it around. And you can see that that point is just on the line x equals -1. Okay, so basically we just need to, do we need to find y? Which of the following, oh no, we need to find an angle. So which of the following could be the positive measure of, okay, let me label this one. This was point H. We need to find this. And we know this lies on the unit circle, right? Also lies on the circle. Okay, which could be the positive measure of angle FGH. So we need to find FGH. Again, we know that cosine of an angle, sorry, let me put points. Cosine of an angle is the x value and sine of an angle is the y value of a unit circle. So how do we do this? We could just move this. Actually it's in degrees. Let me change the radians so I don't have to drag the slider as much. And you see right there, that's when it's touching the, no, it's not completely there yet. I think you have to go there, right? You have to type this up to, it's annoying. You know what we could do? We just type in the answer choices. You see, this is hard to exactly pinpoint exactly where it's going to be on the line, but we have answer choices, so let's type those in, okay? And these are in radians, right? So we should make sure we're in radians when working with these. So by typing in these answer choices, we're going to get points on the unit circle, and we just need to find which of those points is on this x equals -1 line, because that's what point H has to have. It has to have the x value -1. So let's just type in these answer choices. Not negative, 27 pi over 2. Okay, that is not on the line, so that's wrong, because that can't be what H equals. Okay, negative 29 pi over 2. That is definitely wrong as well. Let's do 24 pi. That's wrong as well. And then 25 pi, so this must be the answer then. Yeah, you see, that's the only, out of all these answer choices, that's the only one that was a point on the unit circle that's on the -1, x equals -1 line. So D is the answer then. Okay, hopefully that makes sense. We're going to do a much, much harder question. Okay, let's try this one. So see if you can solve this using your skills. And I'm just warning you, this is pretty hard, but try to solve this if you can. Okay. Hopefully you paused the video by now and at least like read it and try to think of an idea of how to solve this question. Let's go over this. So in the XY plane, a unit circle centered at the origin. Oh, let me label these just so you can follow along. So here is O, not parentheses, O, okay. Contains point A, which is at the coordinate 1, 0. So point A, 1, 0, coordinate A, because there are these 2 points. Point B is also on the circle, and we know B does not equal A, so it's not the same point as A. And the line AB has this slope. So it doesn't tell us what point B is, but it tells us that the line AB, so the line that connects A and B, has to have this slope, so a negative slope. So it's probably this way. But it doesn't tell us what B is, and this angle Q equals this, and we need to find the value of cosine of Q over sine of Q. Okay, so we need to find B, right? We need to find what B is to get the angle. How do we do that? We know B is on the unit circle, and we know B is on the same line as A and has the slope of -7/2. So let's get this line. Okay, let's get this line, and then we already have the unit circle, right? We can just do cosine of, I guess, cosine of the angle, sine of that angle for the x and y value, and then just see which value of an angle makes it on that line. So just, if that doesn't make sense to you, let's just walk through it, okay? So if you don't understand this, you should definitely watch my Desmos video. Right now, it's my most popular video on my YouTube channel. Just watch that. I'll also put like I guess a thing on the video right now, so you can click on it to watch that video if you don't understand what I'm doing here. But I'll kind of go into it. So we know the line, right? We know it has to be a line. So we can do y equals mx plus b form. And I'm using y and x1 to just tell Desmos that I'm pulling from the x and the y values from this table. And we already know the slope. So we just type that in, -7/2. So then it's going to find us what b is. So this is the equation of the line, right? This is the line of AB. We know b has to be somewhere on this line. It's probably going to be really close to A, that's my guess, because there's no way it's going to reach there. Okay. And that's kind of relevant though. But how do we actually get the angle, right? So because we know cosine, I guess let's do q, cosine of q. I keep on forgetting parentheses, but okay, so cosine of q, it doesn't matter, okay? It doesn't have to be a, it's just any constant. You could just, as long as you're consistent, right? You don't use a or q, a and q, okay? You have to, as long as it's the same constant, because we just know it's the same angle, that's fine. It doesn't matter which letter, it's just a normal letter. It's just like a dummy variable, pretty much, that you're using to just reference that's this number that you're putting in here. Okay, so we can use q or we can use a. It doesn't matter which one you used. But we know that it has to be here. So this won't be accurate just using the slider. How do we actually get the accurate number? Because if we zoom in on this, we could though. We could just like go back and forth. So 0.5, okay, 0.6, that's too much. So it's between 0.5, 0.6, 0.55. That's a little too low, 0.56. So it's between there. And then you could have done this way. Although I think that would take too long. I mean, it's possible to solve it this way, and then you could just get like a really close estimate of what this number should be, and then just type in cosine q, sine of q, and just see which one fits the best. Actually, we could probably solve it already if we just did that. But I want to show you how you could just automatically have Desmos solve q for you, and this is a pretty common pattern you're gonna have to deal with when you're working with unit circles. So it's kind of important for you to understand this. We know that it must follow this line. Like this point must be on this line. How can we get Desmos to find q for us? What I would do is just, we know b is 3.5, so let's just type in 3.5 here. And I'm just gonna get rid of this so Desmos won't get confused, and just tell Desmos the x coordinate of this line has to equal cosine of q, and the y coordinate of this line has to equal sine of q. And it's gonna automatically solve q for us right there, because basically it knows it needs to make both sides of the equation equal each other, because that's what the squiggly line means. It's basically asking Desmos to find values of constants so that both sides of the squiggly line equals each other. And when it sees y1, it knows, oh, I already know what y1 equals. y1 equals sine of q, so it's going to plug in sine of q for us here automatically. And it sees x1, so it's going to plug in cosine of q automatically, and it's going to find a value of q that makes both sides of the equation equal each other. So basically what we're doing here is finding a point where the x coordinate is cosine q and the y coordinate is sine of q that is on this line. And that's exactly what we want, right? So that's why this works. And it tells us what q is. Now we can just type in the answer, which we're trying to find what is cosine of q over sine of q. And the answer is 1.607. This thing, let me just change it to a fraction, just press that button, 45 over 28. So the answer is D here, 45 over 28. Okay, hopefully this makes sense. And I know it might seem hard, but really the hard thing if you haven't watched my Desmos video, you should definitely watch that. But after you watch my Desmos video, the only hard thing would just be understanding this, which is pretty easy. You just have to understand x coordinate is cosine of an angle, and sine is the y coordinate of that same angle. And that's the coordinates of the unit circle, and you can solve it. You just need to know first of all, how to go from an angle to a point, and how to go from a point to one of the angles. And when you're going from an angle to a point, all you have to do is just type in the angle for q, right? You just get it doesn't matter. Like the angle, just type in the value of the angle, and you can get the point automatically, right? But when you have a point, or at least you have an idea what the point is, and you have to get the angle, you probably have to use some kind of regression to do it. At least that's what I would do. You could just move the slider like here, where we just type in answer choices. If they give you answer choices for the angle, you could just type those in to just see which one is right. At least which one is right according to like the point you want to get. But sometimes it's questions like this which is really hard, and you have to use regression to just tell Desmos what the point needs to have, or like what line the point needs to be on, or like what the coordinates of this point it should be on. And then you can just have Desmos solve for the coordinates for us. Like for example, if we knew that the x coordinate was going to be 0, we knew the y coordinate was going to be 1, it would be able to solve for q for us if we just if we type in a regression for that. Let me do that. So we know this point has to equal cosine and sine of q, right? And it's going to solve for q for us. Let me make sure q isn't defined there. Yeah, there we go. It's going to solve for q for us to make sure that it goes through these points. And if for some reason you need to find a very specific value of an angle, for example, for these questions, the angles are really high, and Desmos in regression tends to give you a lower number. You could just force Desmos to give you a higher number by just telling it like the angle q has to be a number greater than, for example, 2 pi or something. And it's going to give you a number greater than that, but still make sure that both sides of the squiggly lines equal each other, meaning this value, this value equals this x coordinate, and this value equals the y coordinate, and it'll still work like that. So if the question requires you to go from a point to an angle, you probably have to use regression to solve it, which is why I strongly recommend you watch my Desmos tutorial YouTube video if you haven't already. And other than that though, you just need to know this, and you will be able to solve every single type of unit circle question that's going to appear on the SAT.